So today I'm talking about when pipelines become sewers, 7 wastes of data production. I'd like to start by acknowledging the Wurundjeri people who are the traditional custodians of this land. I'd also like to pay respect to the elders, both past and present, of the Kulin Nation, and extend that respect to other Indigenous Australians present. So I'm David Colls, and mainly what I try to do is create the right conditions for data teams to do great work. Today I'll be talking from my experience in the ThoughtWorks data and AI space, also from my experience at ThoughtWorks in lean transformation prior to that, and then prior to ThoughtWorks, my experience in advanced manufacturing. So it's going to be a bit of a multidisciplinary talk, but it's going to focus on data engineering. So we're talking about pipelines today, and this is a picture of the Golden Pipeline in Western Australia that delivers water from Perth to Kalgoorlie over 500 kilometres into the desert. This pipeline was built 100 years ago. It's expected to last another 100 years. But in my search for images of pipelines, I also came across the Banzai pipeline, a wave in Hawaii. And I thought, well, every day as data professionals, we're awash in a sea of data. Occasionally opportunities rear up and we have a limited window of opportunity to take advantage of them. And so this is potentially another model of a pipeline that we can think about. And if we think about the fluid nature of the ocean as well, it also presented for me an image of waste and, you know, the tragic problem of plastic waste in our ocean. But if we think about waste in complex systems, it gives us a useful metaphor in that waste in our oceans, it's very hard to tell where it comes from. It's invisible, although we know in aggregate, but where a particular piece of waste comes from. It's invisible for a lot of its life cycle, and it turns up in the most unexpected places. So we find similar things happening with complex data systems. And I've talked about wastes of data production. So please come in, there's a few seats free up at the front. So I'm also working on a model of data production, and that is the idea of an analytic data factory where we have producers of data at one end, and they are delivering operational data, which reflects the changing state of the world into the factory. Through the factory, we have numerous transformations that ultimately deliver an end state analytical product that is useful to consumers. So that's a pretty simple model of the factory. It gets more complex because in any organisation of any size, we have multiple producers with multiple different needs. And we have multiple consumers also with their own needs. So we're seeing this pipeline repeated over and over again from producers to consumers. It's also not the case that everything's so clean inside that factory. We have people, communication, process, technology, legacy issues. Basically, the factory is haunted. But we're going to stick with this simple model to talk about waste in data pipelines today. And when we look at our data factory, there's also 2 lenses that we can look at it through. The first is running the factory every day, every hour, every minute, every second, depending on how you're delivering data products in your organisation. You're running this factory. You're taking the raw inputs and you're delivering useful analytic data products out of the factory. But as data engineers, we're also constantly building and evolving that factory. We're creating new connections from producers to consumers. We're evolving existing connections, and we're even evolving the whole paradigm on which the factory is built by introducing new tooling and new ways of working with data. So today I'm going to look at those through both of those lenses with a lean perspective on where we find waste in data production. And in the run model, we can refer to physical manufacturing, where lean has a long history of identifying and simplifying systems to remove waste. Also in the build, we have a model of waste in knowledge work or software development. Judah, Mary and Tom Poppendike did some of the original work on this, and they've mapped those lean manufacturing wastes into the knowledge work domain. So when we're doing knowledge work or we're building systems, digital systems, we can identify similar forms of waste to what we might in physical manufacturing. So we'll use those 2 lenses today. And why should you care about these lean models of waste? They've been useful for me in my experience, and as I said, this is a multidisciplinary kind of talk. It helps you identify waste you didn't know about initially. You might not have thought to go looking in a particular place for waste. It also helps you define and articulate the impact of things that you're seeing that are far from perfect in your everyday work. From a lean perspective, it might help you. I think a lot of you might already be doing some of the things that are suggested as solutions here, but it also helps you understand how those work, how they might be more effective as well. And it also helps you build allies outside of core data engineering functions inside organisations to improve the way we're working holistically and tackle waste that you're not responsible for. So let's dive into data production and its wastes. And as I said, I'll try and keep in the time, but I've got 7 wastes, 2 lenses, and then 5 lean principles to follow up with. So it doesn't leave me much time per slide after 9 intro slides. So in COVID times, you might have seen photos of overflowing car holding lots. Here, supply of vehicles was far exceeding consumer demand for a time. And this is called overproduction in lean manufacturing. It's building things that customers don't need, or it's building too many of the things that they need. I think we can all relate to this in our data factories as well, of building data products that consumers aren't actually using or that they don't need. Maybe they need it at one point, and they don't need them anymore. And so these could be reports that no one reads, but also it might be hard for us to determine whether anyone actually reads that or not. I'm sure that's a pretty common scenario as well. Do we know how much value we're delivering from our analytic data products? So we look at the run phase. This is unused products, where the factory is running every day to produce unused products. But if we look at the build phase, it's also the effort that goes into building those. So both of those are sources of waste. How big is this waste, you might ask? Well, some research in the software engineering space shows that up to 50% of features that are built into software products may be rarely or never used by the end users. So although the actual number may vary, I think this is an important yardstick to keep in mind, or a point of reference when it comes to overproduction, especially as in the data space, it can be hard to tell whether consumers are using our products or not. Before we get to the finished product, we also have a lot of work or material flowing through our factory. And this is probably one reason it's good to have a little bit of time up my sleeve. I think I need to be connected to the internet at this point. But I'll talk about the waste of inventory while I try to get connected. In fact, I'll probably just describe this. Apologies, let's go back and forward. So that was actually a video, I don't know if anyone can bring it to mind, of a forklift crashing into a rack of cheese in a factory in Shropshire in England. And basically there's a huge warehouse, and one rack of cheese after another falls down, and all the inventory, all the stock in the warehouse is destroyed, and it falls on top of a forklift that's operated by a person as well. Luckily that person didn't get hurt. But this is to describe the waste of inventory. Material that we hold before it turns into end products is described as inventory. And so inventory incurs a direct cost in, say, in the manufacturing space, in the warehouse, and in the raw materials that have gone into it. It also represents a risk that we might not be able to realise any value from that inventory, as in the cheese factory example. All that inventory was spoiled and we can't sell it anymore. And then beyond that risk that we can't realise any value, it also can potentially cause harm. So we're thankful that the forklift operator wasn't injured in this case, but there would be the potential to cause harm. If we look at the data space, we've seen a lot of harm caused by data inventory that's leaked into the public space over the last 12 months in Australia. And so I think it's a key form of waste, but also a risk of not realising value and a risk of not causing harm that we need to address in data systems. So in run, this could be stored or processed data that's not used. So this could be anything that winds up in a data lake but isn't actually being made use of in an analytic data product. And in the development phase, it's also anything that we're working on that hasn't made it into a production environment or an environment that's used by end users. So how big can the waste of inventory be? Well, from industry examples that I've seen, I think it can be effectively unbounded. So any data program could, if it hasn't been able to deliver valuable products, it could be wound up, only having delivered inventory in terms of data and systems. So another potentially large form of waste. And accountants also have a point of view on this, as well as lean practitioners. So in accounting, there's a different definition for an asset and inventory, and it comes down to the distinction is how likely you are to make use of it. And I think that there are opportunities in the data space to have a much more nuanced conversation about, do we hold data assets or do we hold data inventory? And I know it's hard ahead of time to determine whether data is going to be used for a particular purpose, but I still think it's a useful conversation to have. So we've seen a few wastes of too much stuff. What about processes that have too much in them, that are too difficult to work with? So the first process waste we'll look at is the waste of over-processing. And I think I've heard in a few talks today issues that are caused by lack of trust in data. And I think that this is the root cause of over-processing, which is doing too much. In the manufacturing space, over-processing could be, for instance, polishing a part, drilling a hole in it, and then polishing it again. We should actually rethink that process to make sure we're only doing the minimum value add at each stage. In the data space, we might do a lot of extra processing to compensate for untrusted data in the run mode of the factory. So this could be anything from trying to impute missing values to a single view of customer entity resolution. I know that the solutions are not necessarily straightforward to this, but they're ultimately examples of over-processing because we don't trust the source data enough. And in the build phase as well, working with untrusted data causes us to constantly go back to first principles, ask if we can reproduce someone else's result, understand the variation between 7 very similarly named columns. So there's a lot of what's called relearning in the wastes of lean knowledge work. There's a lot of relearning that happens in our build phase of our data factory when we don't trust the data. So the key question, I think, from this process perspective is how much trust do we have? Because the level of over-processing will be in inverse proportion to the amount of trust that we have in our data. One of the reasons we might not trust our data is that we might have lost its thread. We might not know where it comes from. We might not be able to follow it back or repeatably reproduce it. And so this is in a factory. This is the waste of transportation. If you're moving things around, then you could drop them or bump them into things and damage them. And so this represents a form of waste. In the digital space, we can make perfect copies. So how do you damage things by copying them digitally? Well, I'd contend that it's by losing that lineage as you move things around. That's how you damage a digital artifact or a data set that you're working with. And so this is where the waste of transportation comes into running our factory. In knowledge work, in building the factory, then if we lose that thread between people or teams that have context of the reason why we're building something or the success factors for a solution, then that's where you damage knowledge work as you transport it from one place to another. So handoffs between teams are where we see this come up in build. And so the question to ask here from a process perspective is how many handoffs? And as well, sometimes when we're working in a process, we're just simply doing too much. It's harder than it needs to be. And in lean, this is described as the waste of motion. And so this could be workstation set up in a factory that's unnecessarily difficult to use. It's not ergonomic. A drill is over here, a clamp is over here. It's not all where you need to do your work. And so in the run phase of our data factory, this could be where we're finishing products manually. So this could be where there's a manual step that's required or repair errors that have happened in a pipeline, finishing a document in Excel rather than having a fully automated report. And in the build phase, it can be working across different contexts. So if you have to constantly shift from, say, a customer context to a product context to a spatial context, for instance, with your data, then each time you shift, that represents a context shift. It's extra work that you need to do, and it's an impact on you as a human trying to do work in a complex system. So this is the waste of motion, and the question we should be asking is how many contexts are we expecting our data engineers to work across? Almost opposite to motion is the waste of waiting. And so we might all be familiar with having to wait for an upstream process to finish or wait for a downstream receiver to become available, either in the run mode. So any delay that we introduce into being able to take action from a business event in the world represents a waste of waiting when we're running our factory. We don't always need to respond immediately, and so the SLOs are going to vary from case to case, but where there's a delay between where we'd like to be able to take action and where we actually are able to be able to take action, that's a waste. And in building our factory, every time we have to wait for feedback or wait for input from another team or wait for an environment to be available to test something, that's going to introduce waiting as a waste as well. Ironically, when we have slack due to that waiting, we tend to pick up more processing or more work, which increases the inventory in the system. And that then makes it harder to push things through on a short cycle, which increases the waiting again. So we start to see how some of these wastes start to reinforce each other as well. And so when we actually had an opportunity to study how tasks flowed between teams in an environment, we found that tasks that went outside of a team took 12 times as long to complete as tasks that stayed inside a team. So the waste of waiting can quickly amount to an order of magnitude beyond what work that flows well or data that flows well might be able to achieve. And we're nearly there. Thanks for sticking with us for the first 6. Finally, I'm going to talk about defects. And I mean, maybe some of you thought this is where we would start talking about waste. And I really like this picture because this demonstrates that defects can happen at any stage, including requirements. So this is a perfectly executed defective requirement. And so defects in our factory, we might see them introduced at any point. So defects in collecting the source data will then propagate all the way through. If we've built defective transformations, if we've used a lowercase m instead of an uppercase m, and we're collecting records from every minute rather than every month, then we've got an issue in our transformation. And we might, as per that example, we might have defects in our finished products as well because they don't meet customer expectations. We've failed to do something that the customer expects. So the waste of defects is that all that time we spend on defects could actually be spent doing productive work instead. So our ability to reduce defects and to catch them as early as possible in the process opens up a lot more productive capacity for the team. Given all of those wastes, what should we do about them? And if I had a lot more time today, we could go into a lot more detail, but I'm going to share with you 5 basic principles from Lean that can be applied to any situation. But first, I'm going to dive a little bit deeper into that notion of the cumulative effect. So we saw each of the wastes individually, and this is also a bit of a picture about how they might add up together. And there's lots of different cause and effect pathways here, but here's one journey to take. Starting from overproduction, we're doing too much of everything. So we have an inefficient process, we're doing it too often. This poor process can cause waiting, as we described, as we wait for things to synchronise or because we do too much in one part of the pipeline. And those handoffs or transportation or motion are a key source of introducing defects. As I discussed earlier, so those defects, waiting and defects can make it harder to realise value from our inventory. It puts more of it at risk because it's further from winding up in the hands of consumers who find it useful. But then also having that inventory makes it harder to get work through the system in a short amount of time. With all of those visible issues of delays and of defects, it makes it harder for us to address the root causes in the process of overprocessing, transport and motion. And when we have all of these things going on, it's very hard to talk to consumers about value. It's hard to build the trust that maybe if we did less, we could achieve more. So all of these issues can reinforce one another. And so looking at all the individual effects, the cumulative effect can be a lot greater than any of the individual effects. So what are the principles to address waste? We start by defining value in this 5-step process. With value defined, we're able to map the value stream that takes raw materials and turns them into something that consumers value. With the value stream mapped, we can then look at creating flow through that value stream. And so being able to deliver data or work in a shorter time as possible, because the shorter the time, typically, the less opportunity we have to create waste. And then when we have a system where we can reliably deliver value in short cycles, we can change the frame from pushing out things that consumers might want and only finding out after the fact if they wanted them, to actually responding to consumer needs on a much shorter cycle, which is about establishing pull. And then continuously improve. So with small steps, we can improve each of those parts of the process. And while this might help us address a cumulative picture, there's also a little bit of an affinity with the individual wastes as well. So defining value is really about tackling overproduction, having an upfront conversation about the things that aren't going to represent value to consumers, and focusing our efforts on the things that will. Then when we look at mapping the value stream, we're understanding the sources of waste in that end-to-end process. When we create flow, we're about eliminating that waste of waiting and the consequent defects that arise from poor processes in the value stream. And then we're able to establish pull, which helps us address inventory, and also, as discussed, has a cumulative effect on improving the other parts of the process. So defining value, I think the key concept here is data as a product. And I've talked a lot about manufacturing, a little bit about accounting, but here this is marketing and product management thinking. So this is about understanding not what you're making, but what problems you're solving with it. And this is about talking to consumers. This is the way to find out what problems you're solving. But there is a technology lens as well. We found that it's very important that domain teams can manage this data product lifecycle to be able to work effectively in a data product world. So understanding value, delivering products that meet that, evolving them over their lifetime and retiring them if they don't anymore. And then when you consider scaling up those individual pipelines across many producers and consumers, exposing from data products the affordances that are at an organisational level allow us to manage and govern a set of data products to get maximum value. And in some of our work, we were once asked by a client to build them a customer data platform. We had an upfront conversation about what's the value from this customer data platform. It turned out that there was one use case to support a new product that they were really keen to support, and so we built a single data product to support that use case, and as a result saved everyone a lot of waste and delivered a lot more value. If we go on to the mapping the value stream, so this is really about visualising how people work in the factory and how data and valuable products flow through the factory. So how we do it, we have to take a very wide lens on this, go as far upstream as possible and as far downstream as possible to understand value. So your defects might be found after consumers have used your product. You should really look at that aftercare warranty period as well to understand the whole value stream, because that might be, you might be able to address that earlier in the stream. So keep broadening your thinking about what the value stream is. And again, talking to people at every stage, and even better, getting people to talk to each other. We've found that often people in one part of the process don't have a good understanding of the issues upstream or downstream of them, but by getting people to talk together, we can build that shared picture, which we can then display prominently. I was working with an organisation building marketing campaigns off big data. We went through this process of mapping the value stream, starting at the start of the process and finishing with the marketing team determining creative and finalising a list of targets. With the marketing team, we spent 2 hours and filled a whiteboard with their process, and they said, wow, now I understand why it takes so long to get things done. We filled a whole whiteboard. We then took the marketing team outside and showed them the other 3 whiteboards, which represented the other 75% of the process. And that was an epiphany for everyone involved, that this process was far more complicated than it needed to be to deliver the results. But only possible when you make that collectively visible. Creating flow is about shifting the perspective from the components of the system to what is flowing through the system instead. I think in the data space, and so there's this quote from James Womack and Daniel Jones, things work better when you focus on the product and its needs rather than the organisation of its equipment. In Run, we might shift our perspective from data that's stored in places, data that's delivered to places, to data that's ready to move. And so addressing this trust that we can reliably deliver data to where it needs to be, to the quality it needs to be. In Build, it's about trying to shift away from big batches of work and large upfront planning to be able to really get fast feedback on what we're delivering. And so I think in terms of how to do it, building trust in data so it's ready to move, and reducing interaction costs between teams and team topologies has a good model for doing that as well. In our work with Geoscape, who produce national spatial data, if you've used the GNAF file, you've used one of their data products. We helped them rebuild their data platform using a streaming approach a number of years back. This helped them to create flow from their producers, various jurisdictions in Australia, such as governments and councils, and enable them to deliver products much closer to real time. It's taking a 3-month cycle down to 15 minutes and detecting quality issues within that 15 minutes, which could immediately be reflected back to producers and fixed in the flow. And so by creating flow, we're able to address, get value to consumers faster, but also address some of those wastes that existed in the old process. And then when you have all of those elements in place, you can start establishing pull. And maybe it's because I have been to 6 conferences and done 3 talks that I thought it would be good to finish with a haiku here. And maybe it's because the image of a pull that I found was Naha Matsuri in Japan, which has the world's biggest tug of war, I think. But when you establish pull, you're again shifting this perspective from being able to having to produce a lot of product and get it into consumers' hands, to being able to respond to consumers' needs in a more targeted way. And so within a data organisation, we've got a lot of different consumers with a lot of different SLO expectations, from data scientists doing ad hoc analytics, they want to have access to everything, through to, say, quarterly financial reporting where it has to be right and reliable. And so there's not just one set of SLOs, and so it's very important to understand those different SLOs. And finally, continuous improvement. So you've probably seen a model like this before. It's pretty standard to plan an improvement and to focus on small steps. Plan an improvement, take action, study the results of that improvement. Did it have the desired effect? And then the act is on the improvement process itself, and say, is what we're doing having the intended impact, or do we need to change how we're improving? So take continuous improvement to continuous improvement itself. In our work with clients, with a series of small interventions on a big data program, we were able to, over a number of months, go from this program having no ability to plan to being able to predictably plan its delivery. We were able to double their delivery capacity by reducing the failure demand from 60% to 20% through root cause fixes. We were able to reduce incident detection from hours to minutes, and we're able to reduce manual testing effort by 80%. So with a series of small changes, we can make a really big cumulative impact. As I said, this is a very rapid tour through a lean approach to addressing waste. There's a lot of great resources in these books. So Toyota Way describing the manufacturing application, lean software development describing the application of that to software development knowledge work, and lean thinking and lean enterprise being books that broaden that perspective again to any business problem and whole of enterprise perspective on how to use lean to eliminate waste. In the data space in particular, the DataOps Manifesto is very well aligned here. And so, as you can see, the ingredients that go into it are agile thinking, DevOps, and lean manufacturing. And there's 18 principles there. I think they might have a 19th now as well. But some really great principles for identifying and eliminating waste in your analytic data factory. So just as a cheat sheet to finish on, 7 wastes from a build and run perspective, and 5 lean principles for addressing them. So thank you very much, everyone, for sticking with it in the noisy room.